Two ways of doing this. The first way would be the algebra, will be the graph way. So what you do is you could draw this line, wouldn't you? Everybody see that? You could draw that line. Find any 2 points on the line. So if I select, what would be an easy one? If I select x equals 2, let's say, then I'm hoping this will come out even. I'm just selecting numbers. I'm hoping that it'll come out as an even number. I would choose 0, but it's going to come out as a fraction. Try and choose something that's easier to draw. So what happens there then? Actually, I'll choose minus 2. Never mind. Now, if I choose minus 2, what happens? It's minus 4 minus 3y plus 7 equals 0. And then we can get minus 3y equals, that'd be 3. And then equals minus 3. Y equals 1. So that'd be the point minus 2, 1. In fact, lads, a lazier, better way of doing this, lads, would be something like this. Get y on its own, and you get 3y equals 2x plus 7. Divide by 3, and you get 2 over 3x plus 7 over 3. I could load that into the calculator, couldn't I? Table function. And the table function can do 20 points at once. And I'll just pick 2 points that are easy to draw. Does that make sense? So you go to your table function, excuse me, mode, table, you do 2x plus 7. I'll go from minus 10 to plus 10. And I'll do a step of 1. I'll run through my list. Ah, there's an easy point. Minus 10, 13 is an easy point. Did I put in the, oh, didn't actually put in the fraction. Go again. Now you can see they're all fractions, bar which one. Minus 8 minus 3 is a good one. Keep going down. Minus 5 minus 1 is a good one. Minus 2, 1 is a good one. So if you get that, you can get more than 1 point, 2 points, draw your line. Is that cool? Now, will somebody call me out that equation now in a second, please? So what is the equation for the line in question 12? Yeah. 2x minus? Yeah. Plus 7 equals 0. That's that line there. Now, can anybody tell me what 2 points do you need to test? The 2 points that are in question 12, what are they? Minus 2. You're saying minus 2, 1. Sorry, minus 3, 1. So that one there. And the next one? 3 minus 4. Sorry. Oh, stop that. I'll move it down. 3 minus 4, yeah? Now, it's very clear to see. And the other one was minus 3 minus 1. 3, 1. So they're on opposite sides, are they? Alright. So the points I have drawn there are 3 minus 4 and minus 3, 1. Yeah, no bother. Are they on the same sides of the line? No, they're not. Now, how will the question show this is what we're looking at, okay? So, what you want to know here is that what's this chapter all about? What's the formula that defines this chapter? Huh? D equals ax1 plus by1 plus c all over a squared plus b squared. Essentially what happens is, see this part here? If one of them is negative and the other one is positive, they're on opposite sides. So get this. When that's the x1, y1 value, and the a value is 2, the b value is minus 3, and the c value is 7. Let's find out here, okay? So it's going to be 2 times x1 plus minus 3 times y1 plus 7 all over this, what's it, 2 squared plus, minus 3 squared. Okay, we know that's root 13 on the bottom. So right. On top, we're going to have minus 6 minus 3, which is minus 9. Minus 9 plus 7 is, anybody? Would everybody agree with minus 2? Now, that's minus 3, 1. Minus 3, 1 was the one that was above it. I'm expecting the next answer to be a positive answer. Why do I think it's going to be a positive answer? Because it's on the opposite side. Let's find out. Now, that's a 3 minus 3, 1. Now I'm going to do 3. Now I'm going to do 3 minus 4. Okay. It's alright, but just use the same formula again, except just remove these 2 points. Alright. What am I going to put in instead? I'm going to put in 3 and minus 4. And what do I get this time? 6 plus 12 plus 7. 6 plus 12 is 18, plus 7 is 25. So the first answer was minus 2 over root 13. Sorry, modulus minus 2 over root 13. And the second answer is the modulus of 25 over root 13. You see the way one of them was a negative and the other one was a positive? This proves they were on opposite sides. Yes. Yeah, without doing the equation would work as well. One would be negative and the other one would be positive. So what Barry said there is why don't you just use this part only? And if one of them's negative and the other one's positive, they're on opposite side. Yeah, that works perfect. This works perfect as well. Now, let's test our theory one more time. I'm going to pick another point. And I'm going to pick a point here. Let me see. I'm going to pick a really easy point. 0, 0. Which side is 0, 0 on? It's on the same side as 3 minus 4. Does that make sense? So it should have the same sign as 3 minus 4. Does that make sense as well? Let's test out our theory. So I'm predicting that this should have a positive 25, a positive answer. If I use 0, 0, it should be a positive answer. And is it a positive answer if I use 0, 0? It is, isn't it? It's a positive 7 over root. It's a positive 7 over root 13. Is that right? So because it's the same sign, they're on the same side. All right. And as Barry said, you can pretty much just strip all this back anyway. And you could also do it this way as well, where you just ignore the root 13. And your two answers would be, you strip all that back. And you could say that one answer is minus 2. And the other answer is plus 25. Because they're opposite in sign, they're on other sides. All right, so you have a choice what you want to do. Now let's move on. 16. The length of a perpendicular to a line from the origin is 5 units. The line passes through point 35. Set up 2 equations with 2 such lines. Right. I sort of started this roughly yesterday, very rushed at the end. You have 0, 0. Is 0, 0 on your 2 lines? Is 0, 0 a point on the 2 lines you're looking for? Yay or nay? Why? It says the distance from 0, 0 to these points. So they're actually not on line. So I'm drawing 2 lines that go through 3, 5, but they go through 3, 5, and they don't go through 0, 0, but they should have the same perpendicular distance to 0, 0. Does that make sense? So essentially what I'm saying is the pink line here should be equal to this green line here. I'm doing it by eye, so they should be the same if it were perfect. All right, that's what the question's asking. Now, problem is you don't know the slope, but you know one of the points on the line, don't you? So what can we use? We can use the equation of the line. And then what can we do then? y minus 5 equals m into x minus 3. Y minus 5 equals mx minus 3m. Move it all over one side, you get minus mx plus y plus 3m minus 5 equals 0. Alright, what's your a, b, and c value, lads? Ready? A, b, and c value? A, that's your c. And what's your b value? 1. B value is 1. So a is minus m, b is 1, c is 3m minus 5. Now you're going to do the D formula, okay? So everybody remembers the D formula, the whole point of the exercise. ax1 plus by1 plus c, all over the square root of a squared plus b squared. We thought that. Now, what we're going to do next is we are going to minus m times blank plus b times blank. Oh, sorry. I got that wrong. And that's 3m minus 5. All divided by the square root of minus m squared plus 1 squared. Alright, what's the point we're measuring it from? 0, 0. That worked out nice and handy. What's the d value? The distance from 0, 0? 5. Right. So this is probably one of the simpler ones. So 5 equals 3m minus 5 divided by the square root of m squared plus 1. What would you recommend doing to both sides? I'd square both sides. So what am I going to get? 25 equals 3m minus 5 multiplied by 3m minus 5, which we all know is 9m squared minus 30m plus 25. Sometimes when you square out the bottom, what you get? M squared plus 1. Cross multiply and you get 25m squared plus 25 equals 9m squared minus 30m plus 25. The 25's cancel, unusual. And what I should end up with is 25 take away 9. 16m squared plus 30m equals 0. So this is going to be highly unusual. And what we're going to get here? Anybody? 2m, is it? 2m into 8m plus 15 equals 0. Okay, then what? M equals 0 or 8m equals minus 15 and m equals minus 15 over 8. Reread the question. Have I answered what I was meant to do? What does the question say? Find the equation of both lines, doesn't it? Everybody cool with that? So find the equation of both lines. So, equation of both lines will be something like this. What's a 3 and 5? Is there a 5, 3? 3, 5? 3, 5. 0 into, oh sorry, 3, 5. Y minus 5 equals 0 into x minus 3. The first answer is y equals 5. The second answer is going to be y minus 5 equals minus 15 over 8 x minus 3. We're going to get 8y minus 40 equals minus 15x plus 45. 15x plus 8y. Did anybody get this out? Oh, somebody got it out. Brilliant. You get those answers? Can I ask you yeah, a quick favor in a second? I'm going to draw it out for you on GeoGebra, just to show you what you're actually dealing with. So I'm going to ask you to call that out for me while the other lads are taking it down. Okay. So what are the two equations again? One of them's y equals 5. That was easy to remember. And what's the other one? Yeah. Plus 8y, yeah. Minus 85 equals 0. Where's minus 85? What's the answer in the back of the book? Huh? Yeah. So that's the answer in the back of the book. And it's equidistant from 0, 0. Sure it's not 75? 40. Oh, check the back of the book again. Alright, so here's the deal. I know. I drew the two graphs here. Everybody see that? Hey! I drew the two graphs. One of them's y equals 5 and the other one is the other line, yeah? We're looking at the point 0, 0, aren't we? Degree 0, 0 is here. Now, the perpendicular distance from 0, 0 to the other line, if I just grab this here. I have a fancy way of doing this. It's pretty easy this way. Alright, so once again, here's your graph. Now, if I draw a circle of radius 5, what will that do? That's anything a distance of 5 away from 0, 0. Now, see the way it hits that point there and that point there? So what we're saying is that's a distance of 5 away from 0, 0. And this point here is also a distance of 5 away from 0, 0. So both lines are a distance of 5 away from 0, 0, perpendicular. Alright? So that's what you actually did. End of the question. Now, next one, 17. The vertices are the points 1, 2, 3, 1, minus 2. Find the lengths of the perpendicular from A to BC. A to BC. Alright, that's handy enough. Here's what we're going to do. We need the equation of the yellow line, and then we need to find the perpendicular distance from the green point. How do I find the equation of the yellow line? You need to get the slope, don't you? Using y2 minus y1 over x2 minus x1. You guys know how to do this. It's child's play. So can somebody just give me the slope? What do you get for the slope of BC? Huh? 3 over 4? Anybody else get 3 over 4? Excellent. Well done, bro. Alright. I'm trusting we can all do that. Next thing, we're going to get the equation of the line. And the equation of the line is y minus y1 equals m into x minus x1. And what we're going to do here is we're going to do y minus minus 2, which is y plus 2. Then we're going to get 3/4. Then we're going to have x minus minus 1, which is x plus 1. Cross multiply and we get 4y plus 8 equals 3x plus 3. Move it all over one side and I'm going to get minus 3x plus 4y. What's it? Plus 5 equals 0. Is everybody okay that's my formula? You get that, Brian? Or the minus 1 version of it? You got minus 3, yeah? Okay, great. Next thing. What chapter are we in again? We're in this chapter where we constantly use the D formula, where D equals ax1 plus by1 plus c. It wants the perpendicular distance. If you go back to your original, see the way this is right angles? That means perpendicular distance from A. So we're going to find that out now. A is 1, 2. 1, 2 is your x1, y1. My A value is -3, B value is 4, C value is 5. Alright, let's drive this through now. So we're going to get a -3 times 1, 4, 2, plus 5, all over the square root of -3 squared plus 4 squared. This is 13, take away 3, which is 10, over the square root of 25, which is 5. And we get d value of 2. Alright, d value of 2. Happy days. Now, what's part 2 want from me? So, part 2 wants, let's find the area of the triangle. Alright, well that's no big deal. The area of the triangle is basically your answer that you got for 2. It's a half base times height. So it's a half the length of the yellow line times the length of the pink line. How do you get the length of the yellow line? Anybody? Length of the yellow line? You could do it in second year. Use the distance formula, lads. Did anybody do a half x1 y2 minus x2 y1? Why would that not really count in this question? Does it say hence or otherwise or hence? Hence means you got to use this method. Hence or otherwise means do whatever method you want. Yes. Can't guarantee you'll get marks. Hence or otherwise, you can do it any way you want. Hence, you gotta think of how part 1 helps you with part 2. Okay, very important you know the difference. Now, so that's not allowed. It would work, but it's not allowed for this particular question. So here's what we're gonna do instead. Do the length formula. So we're gonna do x1, y1, x2, y2. So it's gonna be 3 minus 1. And then the other one's going to be 1 minus 2 squared. Then we get a length of 5 for the yellow line. 5 for the yellow line. And then it's a half 5 times 2, which is equal to an area of 5. All good? Alright. Now, what we're going to do here, guys, is we're going to look at the next couple of questions. Questions we didn't do. I'm just going to give a voice over how you might do them. And then guys, are going to do them tonight. Now, which ones have we not done yet? Have we done 14 and 15? No. Alright. So, would you agree question 15 is a lot like 16 from last night? You use m as the slope and you do the d formula equals 2. Is that alright? 15's rip off of 16. You're doing question 15 tonight. That's your first one. 15. Okay. Any idea how to do question 18? Alright. Here's what you do. Pick a point on the blue line. What's your point on the blue line that you'd like to use? Actually, no, scratch that. Use the equation of a line formula. Y minus y1 equals m into x minus x1 for both equations. Pick 2 points. See the way you have clearly 2 points that are on the red line and 2 points that are on the blue line. You can find the slope really, really easily, can't you? Find the slopes of both lines. Find the equations of both lines. You get what I'm saying? Then in part 2, calculate the shortest possible distance between the two aircraft. That's the perpendicular distance between both of them. So, for argument's sake, please take this down now. Pick the point minus 2, 2. Yeah? Pick that as your x1, y1. And then use the red line as the line. So you're getting the distance of minus 2, 2 to the red line. And that'll give you the answer using your D formula. You get what I'm saying? If you don't, I'll quickly show you. You're essentially picking this point, right? And that point is what's it, minus 2, 2. That's your x1, y1. You have the equation of the red line, so that's going to give you your A, B, and C values, and then you're just going to use your D formula, and you're good to go. All right. It's not as hard as it looks. Right, you should be able to do that. So far I've given you 15 and 18. Next thing. A river flows through its town and its path can be approximated by the line 4x minus 5 equals minus 6. Two friends live at coordinates minus 5, minus 3, and 4, 4 respectively. Investigate if they live both on the same side of the river. What question is this a rip-off of? It's a lot like question 12. What are you going to do? 4x minus 5y plus 6 equals 0. Substitute in the values, in for x and y. If they're both positive, they're on the same side of the river. If they're both negative, they're on the same side of the river. If one of them's positive and one of them's negative, they're on opposite side. It's a rip-off of question 12. Okay? So 15, 18, and 19. And 18 is a lot like question 12 that we did earlier. Okay? Oh, sorry, 19 is a lot like question 12. And 15 is a lot like question 16. Right, let's move on. All right. Question 20. That's unusual. So, anybody care to tell me how you might do question 20? They want a third pipe in the center, parallel to the existing pipes. So where do you think that pipe's going to end up? Somewhere? Somewhere dead center. Are you okay with that? Now I have an idea. Here's my idea for doing this question. Okay? Step 1. I'd like to let me see. Step 1. Trying to think now. Okay. Third pipe. Find the equation of the line to third pipe. It's actually easier than you think. What's halfway between point 2 and point 4? There you go. That can be your x1 and y1, can't it? What's the slope of this line? How do you find the slope of this line? It's the same as the slope of the other two. So you use y equals mx plus c. You get the slope of either one of these two lines. I think the slope is going to be 4 over 5. So you have the point and you have the slope. Means you can get the equation of the third line, doesn't it? What is the shortest distance between the centers of the original pipes? Centers of the original pipes. Okay? Here's what I recommend you do. Yeah. Why don't you just do the D formula? D equals AX1 plus BY1 plus C. And what point could you choose? Just use 2 blue pipes. Use this point here. See the red points? Use that point and use this line, and you'll get the distance, no bother. Alright? You'll end up getting the perpendicular distance, the yellow distance I just drew there. And that's it done. So what did I give you for homework again? 15, 18, 19, and 20. Lads, quickly, I'm going to just